Hello students, I am Dr. Kumar, Associate Professor in the Department of Oral Medicine and Radiology in Vinayaga Mission Sankaracharya Dental College. Today we are going to discuss about the topic in radiation physics. This is the radiation topics. First, the contents of my class is, first is basics about the atom and general energy, then history of X-ray and X-ray machine, the parts and X-ray machines, and production of the X radiation, and then properties of X-rays, then uses of X-rays. These are all my contents of the class. Okay, let's go by one. First, some of basics about the atom. The atom consists of two parts. First one is the central nucleus. Second one is the orbiting electrons. The central nucleus contains proton and neutron. Proton is the positively charged and neutron is a neutral charge. Orbiting electron contains the negative charge. This is the orbiting electron. This is the nucleus. The yellow color is marking is the nucleus. Is a contain positively charged proton and neutral charge neutron. The electrons are maintained there in the orbit by electrostatic force. There are all the orbits. The orbits is different level of orbits are there. First is the K orbit and L and then M. If it's like that, it will be the going around the nucleus. The maximum number of electrons that can exist in each shell of the tungsten atom. This picture shows is a tungsten atom. Each orbit contains the specific number of electrons. According to the formula 2n square, the K shell contains the maximum 2 electrons. The L shell contains the 8 electron. The M shell 18 electron. Like that, we are arranging the orbits around the nucleus. Then, what is the binding energy? There is the energy. The electrons are maintaining in their orbits by electrostatic force between the positive nucleus and the negative electrons. This is known as the binding energy or binding force of an electron. For example, in the tungsten atom, the binding energy are as follows. The 70 kilo electron volt, the KeV means the kilo electron volt, is the K shell electrons binding energy. The L shell electron binding energy is the 12 kilo electron volt. Likewise, M shell is the 3 kilo electron volt. Okay. These are all the binding energy. Binding through the certain orbit, that is called binding energy. So generally, what is energy? In physics, energy is a property of objects transferable among them via fundamental interactions, which can be converted into different form but not created or destroyed. Listen carefully, it can be converted into the different form, one form to different form, but it's not created, not destroyed. Okay, this is the energy. Some of the energy, example of the energy is the kinetic energy, electrical energy, heat, potential chemical energy, atomic energy, and then radiation energy. Radiation also one of the energy source. So what is the radiation? Radiation is the definition, is defined as the emission and propagation of energy through space or substance in the form of waves or particles. Is the definition of the radiation. This is generally classified into two types of radiation. One is ionizing radiation, second one is non-ionizing radiation. What is the ionization? The ionization means the neutral atom contains an equal number of protons and electron. The neutral atom, for example, hydrogen atom, 1 proton and 1 electron. That is a 1. So, equal number of proton and electrons are present in the neutral atom. An atom that gains or loses an electron become electrically unbalanced. This is known as an ion. For example, if remove the one electron, means that is converted to the positively charged ion. We add one electron, that is the negatively charged ion. That's why it's positively charged ion, negatively charged ion. This process is called ionization. Ionization is the production of ions or the process of converting an atom into ions. This is called ionization. Okay. Then ionizing radiation. Ionizing radiation means that defined as the radiation that is capable of producing ions by removing or adding one electron in the atom. Removing or adding one electron means that atom converted to the ions that is capable to some ionizing radiation. That radiation is called ionizing radiation. The ionizing radiation can be classified into two groups. One is particulate radiation, one is electromagnetic radiation. Particulate radiation means the particles like radiation. Electromagnetic means that wave like, energy like radiation. This is the particulate radiation, means I told you that particles, actually the small bullets like that. Okay, this is the alpha particle, the alpha ray, beta ray, gamma ray is the under conclusion of the particulate radiation. The beta particle is a very smaller one, there is nothing but electron. The alpha particle is the 2 electron and 2 protons. That is the alpha particles. Gamma radiation is the wave-like radiation. See that the penetration power of the different type of energy is different kind of that. The alpha radiation is the very large because of the the particulate radiation, but it's the contain 4 atoms. So the small paper is enough to stop the alpha radiation. But beta radiation is smaller than the alpha radiation because of the nothing but the electron crossing the paper, but aluminum is enough, the aluminum thickness of the aluminum is enough for the stopping the beta radiation. But gamma radiation is very powerful. This is a wave-like radiation, that paper and aluminum is not enough, so we need a lead. We lead only the stopping the gamma radiation, and the X radiation also there. You need that stop the gamma radiation. Then electromagnetic radiation. The electromagnetic radiation can be defined as the propagation of wave-like energy through the space and matter without the mass. Through the space and matter, we go to anywhere in the universe. That is the electromagnetic radiation. Then, before going to that part, one more small clarification about the wavelength and frequency. Wavelength is the distance between the crest of one wave to the crest of the next wave. See that? This is the wave-like radiation. See, this is the one crest and this is the another crest. The different distance between the two crusts is called wavelength. Okay. The frequency is the number of wavelength that passes the given point in a certain amount of time. See that long wavelength called number of waves. Number of waves is low in this first picture. Number of waves is more in the second picture. So it's a short wavelength, get a longer frequency. Short wavelength, high frequency. The number of waves is increased. So means the frequency is increased. The shorter wavelength and the higher frequency will be the vice versa. So the penetration power is high frequency, the penetration power is more. That's the, remember, we needed that point. The low frequency, the penetration power is less. Okay, that is the point. Then that is the spectrum, electromagnetic spectrum. This is the important spectrum. Actually, below that there is a non-ionizing radiation and ionizing radiation. In between, there is the visible light. See that ionizing radiation means the radiation capable of remove or add one electron in the atom. The non-ionizing radiation is it's not capable of the adding or removing the electron. That is the definition. The visible light is that here see that the 10 power minus 6 to 10 power 8. This is the wavelength. This is the frequency 10 power 14 to 16. In between that area, the visible light is present. Okay. In frequencies lesser than the red color, there is the infrared. More than the violet color is the ultraviolet. See, this area is a frequency is more, gradually increasing the frequency. Here, the frequency is gradually reduced. Okay, this is the reducing the frequency is less now. This is not a harmful. This is a non-ionizing radiation. In this category, the infrared, microwaves, and radio waves are comes this category, non-ionizing radiation. This is not a harmful radiation, but here, after that, the ionizing radiation, the ultraviolet, the frequency is high, the radiation is a very danger actually. This is the harmful. The X-rays, gamma rays and the cosmic rays comes under this category. This is the ionizing radiation. Okay, remember that. Then the history of the radiation. Radiation history. The history of dental radiography begins with the discovery of X-ray. So William Cornat Röntgen discovered the X-ray on the November 8, 1895. Okay, he is the discovered the first X-ray. It accidentally discovered actually. Some of the highlights in the history. First X-ray discovered in the 1895. Immediately 1 year after that, we are using the dental radiograph. 1896. Remember, see that 1896 first dental radiograph in the United States. And then first 1913 there is a first X-ray tube is invented actually. And then first dental X-ray machine is created in 1923. Likewise, the biting X-ray technique is 1925. The E-speed is actually 1981. The introduction of intraoral digital radiography (RBG) is started in the 1987. Say CBCT, introduction of cone beam computer tomography is dental use in the 1998. Like this is the important highlights of the history of the dental radiography. So before that, going to the chapter, there is some basic definitions. We need to know about some of the basic definitions. So what is the X-ray? X-ray is a beam of energy that has the power to penetrate the substance and record the image shadows on the radiographic film. It is capable to penetrate the substance. It creates the image on the radiographic film. That is the X-ray. The radiation. What is the definition of radiation? It's form of energy that carried by waves or stream of the particle. That is the radiation. Radiograph is a two-dimensional representation of the three-dimensional object is called the radiograph. In practice, often is called the X-ray. This is not a correct actually. X-ray is the term of that reference the beam of energy. The radiography. Radiography is the art and science of making radiographs by the exposure of the film to X-ray. That whole process is called radiography. The dental radiography. the production of radiographs of the teeth and the adjacent structure by the exposure of the image receptor to X-rays. This procedure is called dental radiography. Okay, these are all some basic definitions. You should know aware of that. Next, there is a X-ray machine. The parts of the X-ray dental X-ray machines. The dental X-ray machines can be divided into three study areas. First one is the component part. Second one is the X-ray tube. Third one is the X-ray generating apparatus. These are all the three study areas. Go by one. First is the component part. This is the control panel. The one is the control panel. Second one is the extension arm, and the third one is the tube head. Tube head is the main part. Then second one is the X-ray tube head. Inside that outline picture of the X-ray tube. We will discuss it little later. The X-ray tube is the heart of the X-ray system, X-ray generating system. The components part of the X-ray tubes are lead glass housing, negative cathode, positively anode. There is a three part in the X-ray tube. Here there is the outline. There is one glass tube. This is the cathode, this is the anode. These are three main parts in the X-ray tube. So first, leaded glass housing. The leaded glass vacuum tube that prevent the X-rays from the escaping in all directions. That's why it's made up of the glass vacuum. It's without any gas inside the tube actually. The one central area of the leaded glass tube has the window that permit the X-ray beam exit in the tube directions in the X-ray beam towards the aluminum disc like the collimator. That is the difference. I will tell you later. First, we should know about the filtration. Then the pathway along the pathway of the X-ray exits, there is a two mechanisms here very important. One is filtration, one is collimation. Okay. Before that we go into that, we need to know about the X-rays. The exit X-ray containing two types of X-rays are there. One is high power, high energy radiation, and low energy radiation. So we need only the high energy radiation to produce the image. So we don't want to need a low energy X-rays. So we need to filter the low energy X-rays by using the filtration mechanism. This is the mechanism because we need the filter the low energy X-rays. So that the filtration method is the sheet of 0.5 millimeter thickness of the aluminum is placed in the path of the X-ray beam. They filter out the non-penetrating longer wavelength X-rays. It prevents that. There is some types are there, incurrent filtration, added filtration, total filtrations. Below that 70 kVp volt peak require the 1.5 millimeter thickness of the aluminum. More than 70 kilovolt peak means we need to more than 2.5 filtration of aluminum disc is needed actually. The filtration is only for, we need the aluminum is filtration. So then another thing is the collimation. The collimation is made up of lead. It is a lead plate with a central hole that fits directly over the opening of the metal housing where the X-ray exists. The collimation is used to restrict the size and shape of the X-ray beam. Restrict the size and shape in the rectangular or circular size. Okay, we have to reduce it. So because of the reduce the exposure of the patient. That's why they restrict the size of the film. The collimators are two types, adjustable and fixed. The dental X-ray machine usually fixed collimators are used. They may either have the round or rectangular opening. These are all the collimator. Collimator is made up of lead and the filtration is made up of aluminum. Is that clear? It's a very important MCQ questions for you. Next one is the cathode. Cathode is actually negatively charged. The tungsten filament or coil is present in the cathode area. It produced electrons. When heated, it produced the electrons. Okay. The molybdenum focusing cup with focusing the electron into the narrow beam in direction of the beam across the tube forward the tungsten target anode. The tungsten is the target actually. Because of that, the high atomic number is the 74. The high melting point also, the 3380 degrees centigrade. So the low vaporized pressure. That's why we need a tungsten as a targeting element. We select the tungsten. Then anode. Anode is the tungsten target is present in the anode, which serves as a focal spot, converting the bombarding electrons to X-ray photons. Other than the tungsten target is embedded in the copper stem. There is a copper stem which functions to dissipate the heat away from the tungsten target. The tungsten is the poor conductor of the heat. The copper stem, actually the X-ray tube create the more and more of the heat actually. We need to dissipate the heat in the all over the area. So we need some of the parts. Because of the copper stem is one of the heat dissipating areas actually. See that conduction through the copper stem, convection through the oil surrounding the tube. The whole tube is immersed with the oil actually. That will dissipate the heat. Radiation through the radiator device attached on the copper stem. And the rotating anode also that reduce the some point of the heat actually. This is all the whole anode and cathode. So far we will completed the components of the X-ray and X-ray tube. So they go for X-ray generating apparatus. The third point, this contains the three categories: electricity and electrical currents, circuits and transformers. Okay, first the X-ray generating apparatus in the three parts. The electricity and electrical currents. There is amperage is the measurement of the number of electrons moving through the conductor. Current is the measurement of the ampere or milliamperes. Voltage is a measurement of the electrical force cause the electron to move from the negative pole to positive one. Actually, there is two types of current, amperes and voltage. Amperes means minimum current measured by a current, voltage is measured by a electrical force. Then circuit. There is a two circuit is present in the X-ray machine. One is low voltage circuit, second one is a high voltage circuit. Okay. In the cathode, I told you the filament X-ray, that the tungsten filament is present in the cathode area. It will produce the electron by using the low current. Only use the 3 to 5 volt is enough for that current. Current is enough. The cathode area. Okay. In the anode, after that heating the electron forcefully goes to that towards the anode. Will hit the target. So that potential difference between the anode and cathode is need a high voltage current. It uses the 65,000 volt. Usually our household current is the 220 to 240 volt. It increased up to the 65 volt. Remember that. There is a low voltage filament circuit is only 3 to 5 volt, but high voltage current using the 65 to 1 lakh volt is need actually. Provide the high voltage, accelerate the electron to generate the X-rays in the X-ray tube. Accelerate from the cathode to anode. We need to high energy, high voltage circuit. There is a transformers. There is a two types of transformer is present. One is step down transformer, other one is a step up transformer. Very simple. Here our household current is normally 220 to 240 volt. So we need to reduce the current to 3 to 5 volt in the low circuit, low power voltage. So we need that part is a step down transformer is using for this part actually. And then after that the 240 volt increase the 65,000. In this area, we need a high transformer. The pop transformer is used. Okay, it will be clear. So, that is the production of X-rays. This is the whole picture of the X-ray tube inside the tube. See, this is the cathode. This is the anode. Positively charged anode, negatively charged cathode. Okay, here cathode there is a tungsten filament. This cup is the molybdenum focusing cup. See, negatively charged molybdenum focusing cup. It will be the shaping of the electrons to the sharp angulated to the hit the target. Okay, so this is the part that in the opposite side, the anode side, that is a tungsten target. This is a black area is a tungsten target. This is a copper stem. The whole area is immersed with the oil. Okay, because of the heat dissipation. So once power is on, first we are using the low power current, which create the electron cloud in the around the cathode. Okay, then after that high voltage is on, the electron very fastly moving towards the target, hit the target area. The tungsten atom is hit the target area. The X-rays produced inside the tungsten atom. I will tell you how next slide. Produce the X-rays. This pathway, this exiting pathway. In the pathway with the X-ray through the coming out actually. In this pathway, there is a aluminum disc. Here there is a aluminum disc in the round or rectangular collimator. After that, the shaping of the X-rays and filter the X-rays. Filter the low power X-rays. Only permit the high power X-rays in the round or rectangular shape only. Here is the position indicating device. These are all the whole mechanism. Okay, you understand that? There is the cathode, anode. The anode is a tungsten target. The X-rays produced from the inside the tungsten atom. Next is the general radiation. Inside that once the electron hit in the target, what will happening inside the tungsten target? There are two types of events are happening in that area. One is general radiation. The general radiation is breaking radiation or Bremsstrahlung radiation. That is one of the important question. General radiation or Bremsstrahlung radiation. The second one is the characteristic radiation. It will go by one. The breaking radiation. The electron, this is the atom of the tungsten atom. So electron from the cathode, they reaching the target. The electron passing through the tungsten target, but in that there is a nucleus, positively charged nucleus. The proton will resist the electron. So electron pathway is deviated. So not hit the nucleus or any other electron. You just convert the direction. That kinetic energy will convert it to the X-rays. This kind of X-rays is the mostly 70% of X-ray energy produced by this method only. The electron passing through the tungsten atom will not hit any electron or nucleus. We diverted slow, speed is very slow because of the resistance of the positively charged nucleus. The direction is changed. So the kinetic energy is changed into the X-rays. This is the one part. Okay. So characteristic radiation, what happened in this method? Actually, the electron, the boarding electron hit into the inner side, the K or L shell electron, hit the electron, and that electron will removed, ejected outwards. So the electron is empty, and the K shell electron is empty. Usually the hole is a 2 electrons. So in compensate, the L cell electron will jumping into the compensating the K cell electron. So the binding energy is different from the different orbit. I told you already. The different kind of binding energy, the difference of the energy is converted to the X-rays. This is the characteristic radiation. Then go for properties of X-ray. The properties of X-ray may be classified into 3 broad categories. One is physical property, biological and physiochemical property. We will go by one. The physical properties. X-rays belongs to the family of electromagnetic radiation having a wavelength between 10 Armstrong to 0.01 Armstrong. Okay. They travel through the space in a wave motion. That is a wave motion. In a free space, they travel in the straight line. In the free space, there is a straight line. They travel with the same speed of light. The visible light speed is the same as the X-ray speed. That is a 3 into 10 power of 8 meter or 3 lakhs kilometer per second. They are invisible to the eye and cannot be seen and heard or smell. They remain undetected by any human senses. It's undetected by the human senses. They cannot be focused by the lenses. They cannot be reflected by using the mirror, refracted or deflected by any magnet or electrified material. They do not possess any of the charge. There is a chargeless, smellless, focusless, anything is not detected by any human sense. The X-rays are pure energy, no mass, and they transfer the energy from place to place in the form of quantum. The property of attenuation. There is one important property. The property of attenuation, absorption, scatter. When passing through the matter, the intensity of radiation is reduced. That is called radiation means stop. Attenuation means stop the X-rays. Intensity of radiation is reduced. The radiation energy is taken by the material is absorption, and the sum of is deflected from the origin of the path to travel the new direction through the one direction. Going out is another direction. That is called scattering of the X-rays. Absorption is by material. Some of the material is absorbing the X-rays. Okay. These are all the physical properties. Then go for biological properties. There is a 2 effects, somatic effect and genetic effect. Somatic effect, this ranges from the simple sunburn to severe dermatitis. It's a harmful radiation because of its ionizing radiation. So it will changes the blood supply and changes the DNA, and changes the DNA means it can change the cell differentiation. So it leads to malignancy. The radiation induced malignancy is possible. So genetic effect. This effect is due to radiation induced mutation of genes and chromosome. It affect the DNA. It alter the DNA. So these effects are usually seen in the offsprings of the irradiated parents. It will be this defects to transfer to the generation by generation. This is really the very, very bad effect. The genetic effect also produced by the X-rays. So that we have using the radiation protection. We have to be very careful about the radiation. We have to need some precautionary methods. Okay. Biological. After that, there is a diagnostic properties. This property we are using the X-rays in the investigation. There is a 2 main property actually. The X-rays is the traveling the straight line. The penetration. X-ray can penetrate the liquid, solid and gases. The composition of substance determines whether the X-ray penetrate or absorb. The absorption. X-rays are absorbed by matter, and absorption depends on the atomic structure of the matter and wavelength of the X-ray. And then ionizing capacity. It is capable to remove or add 1 electron, and capable to convert the atom to the ions. Then fluorescence. X-rays can cause the substance to fluorescence or emit the light radiation in longer wavelength. The effect on films. X-rays can be produced an image in the photographic film. This property we are using the X-ray film. X-rays is creating the image in the photographic film. Effect on living tissues. X-rays cause the biological changes in the living cells. These are all the properties. Then what is the use? Use of the X-rays. There is so many disadvantages there, but invariably some of the property is very, very useful for our medical field. That's why we are using that. Okay. So that 2 main uses actually. First one is the radiology. In the radiology field, X-rays. X-ray, without X-ray there is no radiology. So that the diagnostic use of the dentistry and medicine helps to diagnose the various pathological lesions is the first main use of the X-rays. But we need to be very careful about by using some of the precautions. So radiotherapy. Next one is the radiotherapy. The X-rays are used to destroy the malignant cells, malignant tumor, to cure the skin cancer. Radiotherapy. You all know that. Then after that, some of the many uses. One of the uses industry. In industry, the X-rays used to detect the defected radio valves, tennis balls and tires, and used to detect the presence of pearls and oysters, pearls in the oysters, and used to test the uniformity of the insulating material. used to test the quality of the oil painting. In engineering field, X-rays used to examine the gross structures, very large structures. Now we can use the examinations. Used to detect the cracks in the structure and below the holes and metals, and test the quality of the welding, mold and metal castings. To detect the cracks in the body of the airplanes, motor cars and vans. In the spectroscopy field, the X-rays used to identification of elements and their atomic numbers and structures. In photochemistry field, it is used to ionization of chemicals producing the oxidation reduction. In radiobiology, it uses the alteration of the cells and the tissue for the experimental purpose. In crystallography, it uses the molecular structure. It used to analyze the molecular structures. In sterilization, preservation of the food. X-rays are used to preservation of the food. On detective department, it detects the smuggling of precious metals and other contraband goods like opium in sealed parcels and leather pouches. And also they used to checking the personnel while entering the leaving the restricted areas for security purpose. These are all the uses of the X-rays. So these are all my reference, 3 books and their reference. Thank you for watching my class.